Yeah, so hello, that is yet another session of the Clojure Data Science Special, and this one will be about the bridge to the Wolfram language.
Hello, everyone. First of all, technical questions. Can you see my slides and hear me all right? And everything is coming clear to you? Yes, yep. Christopher's saying yes, Daniel's saying yes. I think it's fine. Okay. Clojure and Wolfram Language. So one more adjustment of Zoom annoyances, but it's cool. Okay, so what we're going to do today, just I would love to just talk about this like more sort of back and forth interactive discussion. So I'll try to be brief. So first of all, like, what is this, and how this came about? A little bit about Wolfram Language and Mathematica, and how they are not the same thing, or maybe they are the same thing. Something that's really interesting for us, which is like, how can we use it for Clojure, and other related questions, like why we should use it from Clojure, or what can we get from it, and so on. Some cool things, hopefully, if everything else fails. Is everyone seeing this now? Yeah, cool. So at least maybe some cool things, some pretty pictures, and how this work integrates with existing ecosystem, which is, I think, very much on topic given last session, and like a brief summary of what's been done so far and what needs to be done, and where do you come in, so to speak. So yeah, short story of the origins. Clojure is firmly in the past. It's just we just finished, actually, and every year we are trying to make it something bigger and more interesting than just 2 days of talks. So this year, thanks to the Clojure community and Daniel, we were able to organize all the workshops. And one additional thing that came out was because Stephen Wolfram was one of our keynote speakers, we revisited this idea of connecting to the stuff that he's been building for the last 35 years. So it's built on top of an existing library that's been around for a long time, but which was not maintained. And the main part of the work was done 10 years ago, and it was slightly different than modern Clojure, but still really impressive thing. Wolframite, so this is the sort of pet name or code name that we've been using. So this kind of goes back to the question of why we should care and what kind of an edge it can give us using this this whole other ecosystem from Clojure. First of all, there's the intellectual curiosity and intellectual sort of growth kind of aspect. It's a very cool language, very cool features, very different in many ways, and very similar in some ways to Clojure. More practically, there is huge library of things like in the sort of main namespace that you operate in, which I think they're called the system context or something like that. That's loaded when you open your Mathematica notebook. There are like almost 6,000 functions, and some of them are more like libraries than functions. There's amazing documentation with code examples that you can click on and code and paste in Mathematica and run and kind of learn how it works. This is, I think, very important for us, I think, and in the context of the tools, like all the tools that you guys are building and stuff. It's very well, it is quite polished user experience, which is not super surprising given that they've been doing this for a really long time. So what can we learn and what can we use? Essentially, that's the summary, right? Yeah, first, like, I'm not going to go. I'm not an expert. Well, I'm not an expert in any of this stuff, but I'm just kind of curious and interested in this space. But just a quick look on what it looks like. Wolfram Language is Mathematica. So Mathematica is the product, which is the user interface and the way you interact with the language. And Wolfram Language is the language. So this little, notation that you can see, this little bit of notation that you can see here is the Wolfram Language, and this whole environment is just is Mathematica. So a lot of this was better explained by Stephen Wolfram himself 2 days ago. So I will just briefly skim through this. I will say a word about this because I think this is quite interesting. So this is the language is what they call symbolic, which means that this is mapping a list of names, a list of symbols over a function f, but none of those things have been defined before. Right, and that doesn't produce any error or whatever. It just does something that's reasonable in this situation, which is like mapping produces this kind of output, right? Like and you can do symbolic, kind of manipulation and don't worry about stuff. And a big thing in the language is pattern sort of substitution on symbolic expressions. That's kind of the way they do function definitions and that kind of stuff. And that kind of extends beyond, at least on the surface level, it seems like it extends, the symbolic nature extends beyond just textual form, right? Because we can see like this is a little red dot, which is actually a symbolic expression. This is the same as X here or something like that. And this is because what it is in actuality is this. So you could think about this as part of Wolfram Language, which is really symbolic, and this as rendering, right? So we could kind of think, oh, in our sort of world, this maybe could have been some sort of hiccup, component or something like that, and it could be actually rendered this as well, right? So yeah, so you can always, this is like a postfix notation on this symbol. You've maybe seen it on the keynote. Function application to the argument. So preform, you can see that it's essentially symbolic expressions, but they can be rendered differently. So it's the same thing with different representation. So it's very interactive. So you don't only get those little pretty pictures, but you get this interactive widgets and stuff like that, which I think a lot of you were talking about as well in the previous session. Like if there could be a library, a collection of widgets, like every time we do this kind of manipulate thing or whatever, or whatever, this could be used in all the notebook environments that exist in Clojure ecosystem. The cool thing they have is integration with their sort of text, what do you call it, natural language sort of processing stuff, and Wolfram Alpha, which is another product built on top of this technology. So this is just essentially you type in some natural language stuff and tries to make an interpretation and gives you some interesting results. There's a lot of knowledge built in, so all the like data sets that you would have to browse around on the web and try to find. There's a lot of this stuff is built into the language, and some of like the informational stuff is like, oh, well, when is the sunset tomorrow, or let me just import a bunch of images from a national park service, or have this entity of a person and get the field of association and present it as data set, and that presents all the things that I can know about this, La Corbusier. Bunch of other interesting things. This is a map, which is like, this is key. This is values is a list of images and stuff. That goes back to the interactive and the go to symbolic. And you can do a lot of things, right? Like I said, those functions do a lot of things that are not. There are sometimes like libraries. So I just evaluate this stuff. And it has a lot of support for different parts of human knowledge, for biology, for studying graphs and networks and plotting and all sorts of things, chemistry, and this stuff is interactive as well, and it's three-dimensional about like anatomy and stuff, some machine learning stuff, and that's the kind of thing we've seen already. So yes, this is my notes from the previous session. Yeah, so how can we use this from Clojure? A brief, kind of maybe midpoint check. Is everything, making sense so far? Can you hear me? Can you see everything? Can you bring anything unclear? No? Okay, I'll keep going then. Okay, so this is an example repo that I've made some changes to this today, so I'll push this and you can maybe play around with this a bit later. So so one thing to realize that like the syntax is actually quite similar. We just moved the parentheses one syntax token to the left and change the square brackets to parentheses, and we can start writing Wolfram language expressions as Clojure forms, just like that. And how do we interact with this? And how do we actually do something with this stuff? You have to evaluate this stuff. So the same way you do it in Clojure, this is the Clojure, Clojure form, which is like mapping, a bunch of numbers and incrementing them. The same we can do the same here, right? So we have like an eval function for Wolfram language, and here we have a map that's coming from Wolfram language and a function that's coming from Wolfram language, and we can do the same thing. And if you have something in documentation, you see something in the docs, and you just want to test it out or something, you can just put a string inside of this, and it's gonna be kind of clever and do this. So what happens is like if inside of this eval thing, it's actually a 3-step process, which eval is the middle point of this. So it converts this Clojure data structure that represents Wolfram language expression into the underlying JLink library, which is Java library provided by by Wolfram people. And then we send that to the Wolfram engine for evaluation. And when it comes back, we parse it back into Clojure data structure. Again, that data structure again, so we can, do it whatever we want in Clojure with that. So now, sometimes maybe you use something quite often, and you want an easy access to that kind of stuff, and you don't want to construct those data structures and send them, give them to the eval function. You just want to internet as a more native Clojure symbol, right? So now what happened here is we are passing the plus symbol as a function given the link to the kernel. So there's a default one, but you can pass it as an option. You can have multiple kernels, stuff like that. So this is now just a plus function that takes however many arguments. Another way to do this is this thing. So take anonymous functions as if we could do in Clojure as well, right? So now we could say greetings, and greetings, okay. Hello, and you can see like this X is like interpolated here and stuff. So and a bunch of other things you can just, I want all of those symbols and I want to run them through this interning function. So I can use those symbols, unadorned from Clojure, but you can just load all the symbols from Wolfram language. So now we have those, many things from Wolfram language that we in this namespace. So the W is the name of the current namespace. That's why you're seeing this namespace prefix, which I'm just calculating by doing this little thing. And the cool thing is this can integrate really well with the existing REPL namespace helpers. Like helpers coming from the REPL namespace that a lot of tooling is leveraging in our editors. So this is about like editor integration as well. So so you can here see, I can see, okay, this is a doc string for this function geographics. So I can, you know, even if I don't know Wolfram language, I can quickly kind of check it out the same way I would use. And actually, like if I just type in something, I get auto-completion because those are all the symbols that have been entered in this namespace. So I can say, oh, what is this? And just use my, you know, normal kind of keyboard mappings for getting doc strings into my text editor. I'm just showing this is the underlying technology that's doing that. Cool thing, we can search through the doc strings this way. So you can see, like, I was searching for this string saying 2-dimensional, and I have, like, you know, this is going through all the doc strings and just searching, and I can maybe this way find the function I'm interested in or something like that. Use regular expressions to search through that's another namespace, to search for the symbol names. So whatever you have, like geo, case insensitive. Like I said, they have cool documentation, so why not use it directly? So this is an addition that comes with the library, which allows you to just open relevant reference guide page on the documentation page and just grab the code and try to evaluate it in Clojure and maybe just browse around, because like all those functions are kind of grouped in you know, buckets or whatever, or topics, and that way, that's kind of a cool way to do this. Like if you like know this one function, you then maybe can find the whole guide where this function is included and kind of learn all the other sibling functions, so to speak. So yeah, that's cool. Sometimes you have like a long kind of maybe Wolfram language, you know, expression that's represented as a Clojure form. So you can use this option to just return the links and now sort of click around and learn about all those things. Okay. And use some facilities built into Wolfram language, right? So maybe that wasn't clear, but like when I've this is Wolfram language function, right? Because this is now part of this namespace. The cool thing is that they use different case. They use Pascal cases. So it's rarely going to conflict with Clojure stuff. So for this kind of exploration, it's kind of cool to load the symbols and just use it as you would normally do. So this is a different kind of way of searching for the data related to a given, you know, piece of Wolfram language, and you get like a bunch of, you know, output, and you have to kind of then try to understand what this output really is. So we have this kind of poor man's Mathematica built in the library, which is a small thing that allows you to render some graphical stuff. So you essentially just bring in this canvas thing, and now we can render stuff to that canvas, as you'd see in Mathematica. And like I said, looking here at the output of the you know, one of the function calls that I've made, and it just came back from the information, internal information from Wolfram language about the symbol I've given it to. It's just like, oh, you know, this stuff it's just data structure, so it's quite easy to work with. But maybe sometimes there is already a canonical representation of some data structure in Clojure. So for example, we might want to, like, this is the representation of URLs in Wolfram language. So now it just evaluates the structure, because, you know, because that's what it is in Wolfram language. This is what's the canonical representation of URLs. But we can there's a hook for extending how the things are parsed on the way back from the Wolfram language engine. So for example, wherever we see this head of expression, as they call it, we just cast it into java.net URL. So now if I do this, I get back this beautiful thing here, right? So that's the kind of stuff. So I said, like, that's the editor integration, and then what you can do from Clojure, like very briefly, and the poor man's Mathematica is rendering images into this canvas. But a slightly better way would be to actually plug into existing tools. So, you know, you guys talked about Clerk a little bit, I guess. So this is Clerk rendering those Wolfram language, you know, expressions represented as Clojure data. So, and just the one thing that's used as an adapter to Clerk is this view function here that comes with the library. And for now, there's just one option. It is for this little kind of widget if you want this folded by default or unfolded or something like that. So, so it's just a couple examples of what's happening. So it renders the original Clojure code, renders the translation into Wolfram language expression, and renders the output you would normally see when this expression is entered into, you know, Mathematica or other Wolfram language product. And the same thing here, right? Like a timeline plot of a bunch of entities. So which all are historical events. One of them is World War I, World War II, and so on and so on. And you can unfold this. And this is, you can see on the left here, this was folded by default. So, and those guys are unfolded. So geographics just gives you the Earth and geo image of an entity, in this case, the city of New York in New York State in the United States. Is this some, you know, numbers, plots and stuff. This is just, you know, obviously you can do a lot of plots with this, but this is just an example, just to have this three-dimensional stuff. You know, unfortunately, I don't know if we can do this, you know, the 3D manipulation. This is just a rendered image. The same goes for manipulate. So we maybe can't really do manipulate the same way they do, well, just directly coming from Wolfram language. We could have a widget, you know, whatever JavaScript widget or something that's an extension of Clerk that could intercept, you know, some specific types of Wolfram language expressions and then render better widgets. But one thing you can do, they can give you the GIF, so it's already quite cool. So instead of the manipulate that we've seen here, we're seeing this form. This is actually wrong. This is not the evaluation of this. This is the manipulation thing with the slider was here. Okay, here. So this is manipulate, right? So this is just the interactive thing, and animate just gives you this GIF going through the range. In this case, what is it? 0 to 5. Yeah, probably. So what else? Oh, okay. So this is just a bunch of like funny things that you can do with Clerk and Wolfram language that kind of demonstrate, like, with very little code, you can, you know, do something really kind of interesting, and that combines some Clojure scripty stuff like Hiccup and some tooling that's in that's kind of fresh and interesting in Clojure, like Clerk, with Wolfram language. So different aspects of Wolfram language. So some of those aspects are just normal functional programming, right? Like this is Wolfram language code, which is very similar to what you would do in Clojure. The thing that's kind of interesting and kind of special is that this expression that's kind of nested here is just tapping into that built-in knowledge database that I talked about, and it just takes random 300 random movies, and then is sorting those movies on domestic box office gross revenue, I guess. The point of this, if you want to play charades and you want to have a couple of picks for your charades partner, this will give you something that's kind of well known, probably it's just like a hacky way or you know, heuristic of how to do this. Pick 300 grows and you know, and the actual thing that's rendered here is just essentially this hiccup here, and that's my alias for clerk. So it's clerk HTML and all this other stuff, and it's just rendering results coming through here. So there's a bunch of other things that we could do, but I will head to a close of like a prepared part of this talk. So what has been done, and where do we want to go with this? So the point I think that we've tried to make, or the goal we try to achieve in this sort of phase, is the revival of the Clojure Data library and making it a maintained and viable and project with some sort of longevity, right? And that happened before the conference, in relation to the conference, and Christopher Small, who's here, was involved in that effort, and myself. And I think this is a good goal to have, just to make it really small and simple and easy, simple library, so that people can be encouraged to integrate it into existing workflows and be able to understand it and contribute. What I've shown here was the initial editor and tooling integration, which makes it possible to actually enjoy, you know, using it and have as close of a match to a normal Clojure workflow as you could have. So what's next? Easier to use and documented. This is very much work in progress, and I think this week after the conference, after the preparations of the conference and the conference itself, I'll have to get back to work, work stuff. But during the weekend, next weekend, I'm planning to write up some README and make it actually usable for people, because there is like, now this code lives on like a bunch of branches and all that stuff. So it's not very easy to kind of do this kind of stuff I showed today, but hopefully in a week's time, it's going to be easy. And I think the reason, well, we haven't discussed this with Christopher or anyone else, but I think it's kind of cool if we just make it alpha and kind of let people use it and, you know, and see what happens, and then gather, you know, feedback and issues and all that kind of stuff, and see where we can take it. So integration with the Clojure ecosystem and Clojure kind of ecosystem, testing the scope of our support. We have some good contact with Wolfram people, so we might get some notebooks for testing, so we can translate that into Clojure and see like what breaks and what actually it's actually support, not support. Some more neat examples and things to play around. Interesting to see how we can integrate it in kind of real world stuff and see like where this is actually, you know, useful and performant and so on. And just kind of circling back to the very beginning, I think this is cool for us as Clojurists, Clojurians. I think this works really well, peanut butter and jelly, because it's both languages are very close. Both languages can be called symbolic, maybe Wolfram language a little bit more, because we have more of a default sort of convention about evaluation, what gets evaluated, and some. But when you quote stuff, this is actually kind of the same thing. And they have the M expressions, we have S expressions, and on the other hand, I think it's a good match because they have a different approach, maybe to developing some stuff. So they as Stephen Wolfram said with an interview before the conference with us, what they try to do is capture any possible piece of computation that people might want to use, give it a good interface, good name, and provide the support in this. That's why the 6,000 symbols, you know. But so it's really cool for us because there's a lot of work put into that. But some people don't like it for that reason, maybe because it doesn't have this feel of, it doesn't have this quality of being built out of simple parts and being easily sort of understandable in that way, and easily built on top. So we can like just, you know, pull some stuff that's really interesting, like some machine learning stuff or whatever do we want, get the data back into Clojure, and then use all of our own stuff with the, you know, simplicity that we really like. And this is really cool. We're symbolic, so this is essentially saying why are we out of all the other languages outside of Wolfram language, why are we like sort of ideally placed or uniquely placed to actually have this bridge? Is because of this, because we're very symbolic. We have this kind of complementary nature, and we have a close relation to the JVM. They use the JVM. They use Java, I think, to implement a lot of their stuff. So for a long time, they have had this JLink library, which is really well documented, and it's really, you know, really powerful thing, and it's really easy for us to use. It's doing all the heavy lifting of communicating with the Wolfram language. So but on the other hand, we're in the Java, and we're really close to this, right? We both value sort of interactive experience and maybe different sort of approaches to this, and slightly overlapping in the scientific Clojure scientific community. So boom, that's it. Check it out. It's for now, it just lives under the old name called Clojure Data. A lot of credit goes to the original author, obviously. Check it out. Let us know what's broken and where you would like us to go with this. And definitely, what I would like to see is someone who actually knows, you know, Wolfram Language Mathematica, or someone that's actual data scientists, because by the way, I'm not completely pretending here. I'm not I don't know anything about any of this stuff, but it sounds really interesting to me, so I'm happy to contribute and whatnot. But it would be nice to have people doing real work and having real knowledge on both sides, which is Wolfram Language and Clojure. So that's it. I'm not really into self-promotion, so I'm not going to be like sending you a bunch of links. One thing I can tell you is the project is just this little thing. Oh, wow, it's actually a link. Thing I've been building for a while. You can check it out. It may become something bigger, hopefully soon. But yeah, it's one thing that you can check out that's kind of related to me as me. Thank you so much. And some questions, please, comments, and all the usual stuff. How can I stop this screen sharing?
I think if you scroll to the top, there should be a button that pops up at the top of your screen.
There's only new share.
Oh, really? Okay. Yeah, I don't know if I can. I don't know if I can help there. But first of all, let me just say thank you, Paul. Great presentation. And yeah, Net, I'm now deeply intrigued. Yeah, if we don't get to that today, maybe another time we can chat about it. I'll just say this has been a super fun project to be engaged with. It was great to meet you, Pawel, and work on this together.
Likewise.
Yeah, and obviously to meet the Wolfram team and Stephen himself was incredible.
Yes. If you guys don't know, I'm going to say this time. Christopher was teaching Stephen Wolfram some Clojure ahead of the conference. So
Pawel had like prepared a nice little concise, you know, language introduction. And like I was gonna go in and present that, and like immediately Stephen was just like going in 1,000 different directions, like asking all kinds of other random questions.
Really deep, like how those things are evaluated, and you know how this works, with what's like underneath the namespaces, and like all that kind of stuff.
Yeah, it was fascinating to see how his mind kind of wrapped around it, and yeah, and very fun. So. So if I can, I'll ask the first question here, since I think everyone's got this on our minds. Which of Clojure and Mathematica is the peanut butter and the jelly?
Oh yeah, I mean that's a good question. I was
we
thinking
can argue about that, like, a little debate.
Yeah, hopefully no one's gonna ask these questions, but I was like, oh, maybe this is gonna work. Maybe the way it is now. So respectively, on the left hand side is Wolfram Language and Clojure. I don't know. Maybe the other way around. Actually, I'm not sure.
Yeah, it's which one's sweet and maybe not so good for you, and which one's nutrient. Yeah,
well, that'll mean like the other. That'll
wanna...
probably mean the other way around, right? But,
yeah, maybe. I don't know. I don't want to get too. Both great. I love your comparison here. This is a really great kind of overview.
Yeah, thank you.
The overlap.
Can I say one more thing about this? Yeah, I don't know. I've completely forgot, but yeah, peanut butter and jelly. I think that is actually true. I think all this is just not some sort of like, you know, bullshit sort of thing. But I was thinking about like hosts can, because like there are like Python obviously has some kind of a link to Wolfram Language, and they have a library that does that, and people in Java probably have that. But there's such a big, you know, mismatch between those languages. Like Python doesn't have this ability to interact with J-Link, so they're doing some weird, you know, some external thing, some external queue. I don't know. This is RabbitMQ, probably something else. They put some stuff on the queue. It gets picked up by the Wolfram language engine, and it's more complicated. Right? They don't have direct access to this stuff provided by Wolfram team. So we have, and all the other guys on Java platform have, but we are the Lisp on the Java platform, which is the closest in terms of, you know, philosophy and the way you think about expressing your programs, right? Like we're like this symbolic nature of programs is very close to us, and we're more like maybe the lingo we have nowadays around this is more like data driven rather than symbolic, or you know. But like it's at the end of the day, it's very similar thing. Let me actually show you on that point. Let me show you another thing that I was playing around with today. So we've seen this namespace. Here's another namespace. So I was like, last time we kind of started talking about this, so I thought like I'm gonna just sketch something out ahead of this meeting today. So this is this kind of stuff I was playing around with today. Let me just see if this is all evaluated. So if we wanted to, right? Well, let me instead of just looking at those animations and stuff, let me just come back here, and I'm gonna go back, and it's in examples here. So instead of like, you've seen one notation, right, which is like this geo image, that would be like the canonical way to express this stuff that you can see here. But last time we talked about like there might be a bunch of other ways that are more conducive to thinking in this more symbolic way, right? Like this is like, because we know this is not going to be evaluated to, we don't expect this to get evaluated. Sorry? Florian, I think you're okay. I don't know if I don't know if
I have questions.
Something. Sorry,
I have a few questions.
Go on. Yes, sorry. I went into rambling mode.
Okay,
we can come back to this.
Is this interop purely Java library to Java library? So basically no interop?
There is like, so what we're leveraging, and that was something that's the main sort of benefit of the existing library. That's the main bulk of work that's been done by the original library out there, which is wrapping around this J-Link library, and that's something that's provided by, you know, Wolfram Research Corp, whatever.
When you get an installation, it actually comes with a J-Link jar.
Yes.
And one of the things that we did was just make that process of like finding that jar a little bit more automated, because prior there had been like 3 or 4, I'm exaggerating a little bit, but at least 2 or 3 different approaches to like which J-Link jar do you want to point to, but then it gets a little more complicated. You also need to point to the kernel evaluator or whatever, the kernel binary, and so we set up some better defaults so that it's going to just look in the places that it would think it find it and dynamically bind instead of require like in the kind of at compile time in the build tool specification. So kind of something interesting that's going on here versus like what you would normally do with a dependency. Yeah, go ahead.
And my other question is, there is like a viewer for Wolfram out there. Does this work with the viewer as well, or does this need the full license of Mathematica to work?
It works with the free one. I mean, it's supposed to work with the free one. This is something that needs to be really tested. You know, I like to what extent it works, but even Stephen was really like himself encouraging. He was saying this works. You know, this is going to work with the free one, and you check it out and use it or whatnot. So I think they're fine. Happy for us to use it, and from a technical point of view, it should work as well. And I've had some reports of this working. I myself haven't tried this because I have the Mathematica installation, but I will, like I said, next week, just preparing the README, I will tear it down and uninstall everything, just get the Wolfram engine that's free and see if that's, you know, everything works the same way. But tentatively, yes, it works with the free Wolfram.
Okay. And you said, you mentioned the sort of integrated data in Mathematica as one of the reasons.
Yes.
What other universes or features you think are interesting that are not in Clojure that we only find in Mathematica?
Oh man, I think there's a million lists. Like I think their goals, like from my point of view, I don't know the landscape, so and I don't know, like in terms of popularity, I know like Python is, you know, up there, but in terms of integration of all the tools into one platform and integration of all the useful sort of data sources and all that kind of stuff, it's I think it's the gold standard. So I think they have all that kind of stuff. There's easy kind of interface to work with Wikipedia. I think I have a couple examples here as well of interesting, like let's evaluate, like this is some, you know, you have a text and you want to like, oh, let's detect cities and countries and dates, right? Like this is just one function call. So it's just, you know, it's just a very convenient thing to have that. And I have like some genome data. So all this, you would have to be any kind of scientific, but in any branch of science, they have whole library of things that's built in and operates in the same way. And that is very similar to what we have in Clojure already. So in terms of like how to interact with it. So you can see, like, I can even like, I don't know if you can actually, well, you probably see it because this is capital letters, but like it's Clojure, right? Like this is all Clojure, right? And this is actually even would work with the EFN instead of function.
This is one of the insanely cool things that you can mix and match actually, and like things kind of work.
Yeah, and I mean, like I'm giving to examples of like this, you know, dance of let's go.
It's almost gratuitous. What's going on
it's
here.
just for fun, for kicks, you know, for giggles. So in the let form, this is Clojure, right? We're in Clojure here. We're sort of defining local and using the fresh or, you know, arrow sort of operator. Map v, that's Clojure, but inside of the function, that's coming from Wolfram language. So we're doing this addition. So that's like inside of this, you know, and then so that's Clojure, and then like this is the dot product of those things that's coming from Wolfram language. This is Clojure. This is Wolfram language. This is Wolfram language. This is Clojure.
Can I ask briefly?
Yes.
This w/dot, for example, when you say this is Wolfram language, what you mean?
Yes.
It is a Clojure function.
Indeed.
That takes a Wolfram value and returns a Wolfram value, right?
So this is so those symbols, right? Like this is like we're in Clojure. This is all Clojure, right? So because we use this, I've showed this a minute ago, but like this little thing, if you run this little thing, if you evaluate this little thing, this loads all the symbols. This loads all the symbols, like I showed in the example here, right? So it essentially does this thing, right? So I'm like, or more maybe if you want to see this, right? So I'm defining a symbol, a var that has a value of function. That's the that's going to run the equivalent Wolfram language function on the Wolfram language. If that makes sense. But we're like all the time, like all this stuff is happening here in Clojure, but like in the background, this is just running the Wolfram language code. Like here, this is Wolfram language. But like from our point of view, we don't have to, like, we don't care. Like, let's see if that function is in this. Yeah, I loaded this in this namespace as well. So let me remove even the.
What is the, sorry, what's the return type of the take 5 there? Is it like a sequence kind of thing that gets passed into last? What is the return type of that take 5?
Will it be a vector
So let's go.
or
Can you see this?
yeah,
Here on the right.
list? Okay, yeah.
So that was a sequence? Persistent list. Gotcha.
Yes. Yeah, so it's like it's part of like improving the experience. Like if you expect a vector or like experience or performance, whatever the goals of the library are. Like that's why the start of this work is this extensible parsing that I showed with the hyperlink. So maybe and I think we're trying to do that. Like one of the things that we did on top of the existing libraries, like before like 10 years ago, Wolfram language didn't have equivalent of our hash maps. So they didn't have. Now they have data structure like that's used throughout the language, and it's called association. So one thing we added is like our hash maps map straight to Wolfram language associations, and Wolfram language associations map back to our hash maps. So whenever a function in Wolfram language would return an association, we get a hash map, right? Let me show you an example of that, maybe if I can find one. Maybe that will actually show you. Yeah, okay, let me do this. So here's an example of that, right? Like this is Wolfram language. This is running on Wolfram language engine. So they have like a bunch of library of example data, which in this, like for example, some novels that are in public domain or some stuff like that. So what frequency function just finds all occurrences of things listed here in case invariant way, right? In case variant way. So and returns that as a association Wolfram language, so it comes back in Clojure as a hash map.
Gotcha. What's
oh, go ahead. Sorry, go ahead, John.
I think it is too like it's too easy. The interop is too easy because you start to get confused. Like, what is actually happening?
Curious also about the conversion cost, or is there serialization going on at the J-link layer to this Wolfram kernel?
Yeah, there is cost, but we don't know yet. I mean, I personally don't know. There hasn't been any benchmarks done, so we can just speculate. But I mean, we don't know is the answer. What is the exact cost?
It'd be great to benchmark that for sure. I think that my guess is that the J-link library is doing something kind of similar to what the TechML stack is doing or Neanderthal, and creating sort of these wrappers around whatever other stuff might be going on under the hood in Wolfram's world. But yeah, we don't really have a good sense of that. I mean, my guess is that given how central J-link is as a thing that they support, that it's probably, I mean, well, who knows, but that they probably spend a lot of time making sure that it's at least not egregious. And I would imagine even like pretty good,
But then, yeah, sorry.
Gotcha.
Yeah, I was going to say that's why it's one of the reasons that I've mentioned it would be really good to get people involved who actually work in this space and really care about this kind of stuff, because that'll generate the answers for those kinds of things. And I'm personally interested in many aspects, but I'm not a working data scientist, so it's not on like my priority list at the moment. So I'll be really curious to see that, but I mean, I'm not the best person to do it, maybe. And I would say that there would be, I would imagine there would be a lot of tricks to actually make that work. I think they have like good, interesting story for parallel computing and stuff like that. So I think maybe just if there's big costs, maybe just like front loading that cost or something like that would work. Like just do a lot of work on the Wolfram language engine, come back and then do everything in Clojure or something like that. Maybe there's different kinds of tricks and like that would be available, and I think they would work quite well. But that's the sense, you know, of that I'm getting from what we have.
If I can,
Gotcha.
if I can add something.
So Daniel is, I think, is trying to say something for a couple of rounds.
Sure, yeah.
Yeah, sorry. So just briefly, so we have this choice, right? Whether this take function actually returns a Wolfram value or a J-link value, or whether it always converts to a Clojure persistent list or whatever. And probably if we do want performance, then we should return a J-link value and not convert always. Just at the end, right? Maybe just when we need to print it or explicitly convert, right?
Yeah, I mean, all those kinds of optimizations I think would be available. There is some already infrastructure wired to pass options to all the evaluation functions, all the, you know, the WL, eval, whatever function and stuff like that. So you could potentially, that could be one thing you could do, like, don't, you know, what's the parsing strategy or whatever you want to follow.
Yeah, I wanted to add something to what, in response to what Florian asked, like where is this useful? And I think you touched on some great examples there. That I think, again, like the knowledge stuff is like is the biggest one to me. It's just here we can plug into all of this, you know, wealth of knowledge and the ability to look stuff up, or like ask Google Alpha a question and like plug that data into a data visualization. I mean, you know, or whatever, like some, you know, analysis pipeline. I mean, that stuff is just super cool. The other thing that I think, and then, yeah, as far as functionality, computationally, that's baked in across, you know, whatever sort of scientific discipline, that's kind of the next most obvious answer, I think, as you said, Pawel. I think the third thing is that for a lot of the plotting stuff, you know, like, I mean, obviously we have a pretty robust and rich ecosystem here. A lot of folks are using Vega Lite. There's other stuff going on as well. I think one thing that Mathematica has always really shined with is visualizations, and especially like the 3D visualizations. It's a shame that we can't, like, again, grab things and rotate them around, but even just for like, I mean, something that is not as easy to do in kind of the Vega Lite world is to take a function and like plot it. Like you kind of have to manually go and like get some data points for the inputs and then like compute the results. And, you know, it's not that hard in Clojure, right? Because this is our bread and butter, just do a map thing, you know, but the ability to just stick a function in to a Mathematica plot and have it do even a 3D visualization where you have like a surface kind of plot. That stuff is just super, I mean, you know, like day-to-day data scientist stuff, it might depend on what you're doing, how useful that is, but it's at least one of the things that I'm kind of most excited about, because when I was in school, I did a lot of this stuff and was actually like building, you know, I was building solution manuals for some of the classes that I was TAing for and stuff. And so I spent a lot of time building these really nice visualizations with Wolfram. And so it's one of the things I'm excited to be able to do again. Like
I'm like just doing a live illustrations to whatever Christopher is saying. And just doing, like, he's saying you can, you know, ask something of Wolfram Alpha, and
yeah,
like, you know, this is an example I came up with now. It's just Eiffel Tower height, and you get a bunch of results coming back. Whatever, you'd have to like understand, you know, this output, right? But like it's, you can see the usable information is, you know,
is that over the network, or is that built into the free?
It is over the network. Yeah, it is. I think it is over the network. I think so, yes.
Yeah.
And the other example Chris was, it's like a lot of graphing stuff. So it's like this came to mind, like just, you know, all this network stuff, and it's kind of mixing up the knowledge stuff. Like this is very like important for the human species. Eurovision contest, song contest about network graph and communities, who votes, you know, because that's a classic thing in Eurovision. If you have any, if you've seen that, you know, before, it's just like, you know, the neighboring countries vote on each other and stuff like that. So it's a good example of community plot, community graph plot. So I just added that now here. So, you know, one example I wanted to show before, please think about more questions, and that's kind of the important bit, but I was just in the middle of doing this. So essentially this, you know, this is just what I did before this presentation today. Is like, okay, maybe we wanted to represent this as hiccup, right? Like I was showing you the image. Is that the example? Okay, maybe. So this is the example, right? So, and we were looking at that in here, like geo image of New York City. We had that here, right? Geo image of da da da. So, but like maybe I want to, you know, represent that as hiccup, and that then you kind of think, oh, maybe there's a straight, you know, path to then having a widget that kind of gets rendered in some sort of clerk or whatever environment. So then translation from this, you know, to this form, right? To this form is, you know, pretty trivial. It's just this, right? Well, at least the first cut of that, you know, translation. So do we have this here? Yeah, we have. So I will bring up this canvas thing and do run this, and you can see this renders, you know, again, right? And this is just a little piece of code, and maybe like maybe that could be like an interesting representation for that as well. It's not only because of that, you know, hiccup kind of connection, but also like this kind of feels like, oh, this feels more like typical data structure in Clojure, and now I can do like a simple, I see like, okay, I can just map over this or do whatever. So this is an example of doing exactly that, right? So I have a vector of cities, and I want to get city data, population of that CDC. I translate it back to the canonical form, evaluate it, and see the results back, right? With, you know, quantity of people. Yeah, I mean, just another example here is like you have this little text snippet thing, and you want to do the word frequency thing in Alice in Wonderland. Okay, Daniel, go on, sorry.
Yeah,
Daniel,
yeah, thank you. I was wondering about what we're missing from data visualization that is actually doable in Java, in J-Link, and whether we could embrace that if we lose the browser habit. You know, and I'm so sorry that Vlad just left, because Vlad is all about visualizing in the JVM. And yeah, so how do
can I say just one thing? This is going to be exactly one sentence. I think, I mean, I encourage everyone to check out the documentation. It's really good to just click around and see what's possible. And that would be like already amazing help for us on this project, especially for me, as I'm not doing this day to day. So if someone say, oh, I'm interested in this, and something is broken in that, you know, in molecular biology stuff, then, you know, because they have a lot of this stuff. So checking out the documentation would be cool. Go on, Daniel, sorry, just for interrupting again.
Yeah. So yeah, we will check out, and yeah, anyway, possibly, yeah, we actually said that. Yeah, thanks.
Go on, John. John has a hand raised.
Yeah. question. Can I just challenge you to try to find a data set real quick? Like see how quickly you could figure it out from your Clojure REPL?
I have no clue how about
like
this
how
stuff, but
about
let's go on. I will just open the documentation. Let's try and play around.
Yeah. How about US population by zip code? And then you can get that in your REPL and build something out of it. Or, just to see the result.
Zip code, US population zip code.
Would it be possible to get,
yeah,
I'm just wondering. I had to solve that problem
I mean,
recently, and it would be interesting if
I can like
solved it with.
It's probably going to be
this.
easier to first try it here. Yeah. So what you would do, like for example. Oh, okay. Let's see what
and then it'll tell you what the query was or the language string
it'll
was.
Give you some results, I imagine, and then maybe we can take it from there.
Let's see what that's going to produce. That's going to be interesting. It's going to take a minute because it's going to go over the network.
Okay.
So there's a bunch of stuff here, right? Oh wow, this is quite a lot of stuff actually.
Well, there's a bunch of zip codes. So
sales tax rates, zip code, housing, person, household.
Is it showing every single zip codes? No.
Geographic properties.
Yeah, interesting.
Well, we don't have to get into it too deeply.
But I mean, I would normally, because I would say like, okay, we have New York, for example, right? If we have New York City. So what you would do here is kind of look at what kind of properties have, like if you would do it for cities, for let's like simplify it, because I'm not, that's not my bread and butter. So this is the kind of thing that came to my mind now. So maybe you could generalize to what you're looking for.
Yeah, I see city population there. Yeah.
And I'm seeing zip codes as well, right? So, and population, there's already, you can click on this, right? And that's a cool interactive thing that they have, because everything is symbolic. So even the interactive thing translates into actual code, and then the code runs. So I clicked population, and you can actually see what it does, which is running this. And this is something that you can already take to Clojure, right? And then we can like, okay, city data. So it is very similar to this example I was giving here, right? So we have to know that the function that we're looking for, in this case for cities, is the city data function, right? But we could use the REPL helpers that I was showing a minute ago, like in this main sort of example namespace, and we could maybe do this, right? We could see population or zip codes or something like that. So and then we can like, okay, a bunch of things, the z-test, and now population correlation test. Well, maybe that's not useful here. But yeah, city data. Whoops, sorry, I closed my Emacs. I will need this. I will need Emacs. I'll move it to this another. Okay. So we're here, right? We were looking. Yes. Okay. So this is the example the closest thing I have here. So it's by city, right? So we'd have to kind of find out how to get zip codes and that kind of stuff, but then it would be normal kind of mapping thing over some sort of zip code data function or something like that. I don't know if there's a zip. Maybe it's not like that. There's the zip code thing.
Yeah, you can do like familiarity.
Yeah. You can do some interactive exploration around that.
It's coming back.
Yeah, sorry. And you can like click on stuff here on functions and be like, that's what I said. You can then kind of go to documentation and you see like, okay, city data, that's already kind of giving us some information. So maybe now I can go from this. Okay, city data for Ireland. Okay, for Ohio, like I have a bunch of big cities in state of Ohio. Maybe I can work this kind of stuff from here. So I have some pointers to other maybe this would be kind of interesting, right? Like this sounds like something that's yeah, and that's kind of how you do it, right? Like you get all the districts or subdivisions population, and you could work it out, right? Like from this documentation. And then translational Clojure is pretty straightforward. So if you get that data back, then you're like back in Clojure and you do all the data processing in Clojure.
And I wonder, these are live data sets that they're curating on their system. So you kind of have maybe live data. You don't have to always be updating your
of course.
data sets.
You've got country data. Maybe that'll be helpful for US.
Awesome. Thanks. Appreciate that.
This kind of stuff. Blaine, I think I think John's ready.
Yeah, so I was inspired by Stephen's lecture, and I downloaded Wolfram Alpha, and so it gives you a REPL. But if you try to get some of the chemical information, or like generating a 3D structure, you'll get back just a graphical a message saying that a graphical image is created. So some text, but not the actual graphical image. So I went on and I downloaded the kernel for Wolfram Alpha for Jupyter Notebook, and in that I could get the 3D. I could get the image of the molecule instead of just text. But the Jupyter Notebook has the same problem that you have in terms of not being able to rotate the molecule around. But there is available a 3D mole JavaScript library for viewing molecules in 3D in the Jupyter Notebook. So it might be a way to tap into that.
Maybe, yeah. And there's also a hack, right? Because I think all those rendering functions for 3D can, what do you call it? Not projection, but what's the English word for that?
Pan or move the camera.
Yeah, you can like specify. I want to see it from this angle, from this angle, from this angle. So if you like, it's not as good as being able to interactively just kind of muck around and kind of look from whichever angle you want. But it's something. So you could like maybe loop over a bunch of things and you kind of show you from.
Or you could probably even animate it, right? I mean, you should be able to animate that.
Maybe you could, yeah. Of course,
right.
Yeah. What's that? How do you change the view angle or view the camera position or whatever they call it?
I think let me see.
Because I mean, it's all symbolic. So if you do the animate thing around it, like wherever you plug that thing in, I'd imagine it would work.
I've seen it somewhere. So there's a couple of options. Oh, maybe I just need to do this. Let's see. Okay. Axis viewpoint. I think that's the thing. Okay. So there's a bunch of those. It's not like you can't really specify exact thing, but you have a bunch of
viewpoint.
A bunch of viewpoints. So you can maybe if you get to know which ones are available, you could just map over those viewpoints and stuff. So you can see what it is. Essentially, it's just like a named parameter, and you give it like this little thing. Well, maybe it actually can be continuous because it looks like it could be.
Right, yeah.
That's some sort of rotation. Let's see if there is documentation for this viewpoint. So there is documentation. So you can see, okay, directory in front. And so this is what the numbers are mapping to in terms of like, your human understanding of what the actual angle is, right? And you can probably work out from this, like how to get the actual, like, let's change this, for example, to -2, which should be left-hand corner. -2, -2. That was, the last one was 0, right? For the left-hand corner. Yeah, so that's changing the point of view. So you potentially could like in Clojure map that to like 50 things ahead and just have a GIF or something like that. I'm
a protein crystallographer, and so we work with 3D structures that have like tens of thousands of atoms. So the need to move in and out and is really important. And so just changing orientation or viewpoint isn't going to be enough. But it should be possible to visualize such large molecules.
Yeah, of course, yeah.
Yeah, I'd be interested in working on pushing that.
Definitely, yeah. Check out the repo, and like I said, like in a week's time, I hope to have something that's slightly more friendly, at least a starting point for someone like you, that can, you can just check it out, download, and so there's a simple description of how to get going with this. And we would definitely appreciate any help from knowledgeable people in, any field. Daniel got born this period. Well, if there's no more questions, I guess that'll be that for me.
Yeah.
I would probably stop sharing the screen now, but I can't.
So I want exactly this, but only in Clojure.
It
Exactly.
is. Well, I can give you the second best thing. If you squint your eyes, it feels like it's almost in Clojure, but it's not.
I have this already developed. Most of this, and it should be possible to do much more.
That's cool. Well, definitely do play around with this and see, like, where can this be applied, or where can be improved, Go on, Daniel.
Yeah. Is it okay to ask about, your experience looking into an old Clojure library and refreshing?
That is an interesting point, actually. I mean, last time I showed you a good example of the change. So I'm not gonna try to flex and come up with something original. So I'm just gonna look up the same thing. It's gonna be here probably, right? So overall, I think it was really great that, there's a lot of work that's been put into this original library, but it was really interesting to see, like, how much has changed how much and how little has changed in Clojure, right? Because this library has already been quite easy for us to work with and get working. It was just well, relatively speaking, we some mechanical changes and some sort of improvements, and it was already working. But there was a lot of reliance on macros and dynamic bindings and stuff like that, which I think are not very popular in Clojure anymore. I think it was very early days of Clojure, and that was kind of like the typical kind of Lisp way of going about this. So it was like layers and layers and layers of macros. So what I'm talking about is not just having a convenience thing or having a macro when it's necessary, but it was just like really committed to having this tower of macros. And at this point, there is no macros in the library, I think. So it's all just data and functions. So I just have here an example of a change that's kind of result of this effort. So on the left-hand side, you see, like, this is some custom function for handling options, which is not even similar to any existing macro. So you can't really work out what it does without diving deep into the code. So it does something with this and with this and this. That's some normal let here, but then here you have dynamic binding. It's doing a bunch of things here, but then you have some other macro here, which is difficult to understand, and dynamic bindings here.
Yeah, if I can editorialize a little bit here, I was kind of most involved. Oh yes. If I can editorialize a little bit here, I was mostly involved kind of earlier on, like doing a little bit of the JLinking cleanup and kind of smoothing out the API a little bit. But yeah, this was such a challenge, because in cleaning up all this old code, there was weird formatting stuff, and you know, just nothing would lint with Condo. And so it, you know, it just really brought home like how much I've grown to appreciate that tooling in part. But yeah, and in the second part, it did highlight kind of what Paul was talking about here, just like was a kind of interesting recognition of like how much has changed in the Clojure community since then, in terms of our usage patterns and stuff. But yeah, definite props to Pawel for taking on these macros, because I was going through and thinking like, oh man, there's no way I'm gonna
I mean,
follow
for me,
this nest.
It was just a necessity at some point. So I was like, we really wanted to get this going before the conference. And one thing that we wanted to have was this translation between Clojure hash maps and Wolfram language associations. So I started working on this, and I was like really struggling to add that. And it looked like a simple change, like should be like maybe 2 places that I need to change, one in the path to the Wolfram language and one the return path. And but like just untangling like how it goes through all this stack of macros was really difficult. So I was like, oh, I need to clean this up. But I started doing that. It's like, it's, you know, I shouldn't really be doing that, because this is like a big construction of macros. But in the end, I couldn't make the change. So I just, you know, I just had to clean this up in that way.
So you're saying 2 things here, which are interesting. One is that our culture changed, right?
Yes,
very much. But the other thing is that it worked. The old
Indeed,
code
yes.
did work, and
this,
that is kind of, that is not obvious, right?
Yes, yes. I started with like how much and how little it's changed, and those are exactly those 2 points you're making, Daniel. Which is, one is, you know, we could really, the library worked, and we were able to work with the library without too much trouble. But then, like on a deeper level, like a lot of cultural things about writing Clojure have changed. So to make it accessible for modern Clojure developer and to make it familiar, like there had to be some changes that made.
Yep, fabulous. Any more questions?
Yeah, just want to say this was like a perfect closing keynote for Reclojure.
Thank you, Daniel. I really hope like I really hope like there's going to be some you know, some interest in this, because I think it can be useful for many people working in Clojure, but it can also be really fun, because this really small project and it's very old, but like the revival of it's very new, so everyone can contribute and make their mark, even someone like me who's not a data scientist. And also I think it's kind of interesting for us to look at what they've done in 35 years and see what we can learn and what we can borrow, and where we can improve upon, you know, whatever it's been done by them. So it's a good source for inspiration for us as well. It's like how to, especially in my opinion, in terms of around like how well integrated this whole story of symbolic expressions is, and being able to express you know, a lot of things about the world that way. And I think we've made a lot of strides in that as well, with like our focus on data, and you know, so that's kind of cool. And the other aspect is all the interactive stuff that's an user experience that's in Mathematica, that could be really cool if it's, you know, transplanted and maybe it's surpassed in Clojure, like Florian was saying.
Yeah, if I can add anything here, I think it's just that for me, this project has been a reminder that, you know, we have a lot more to gain from being really cooperative with the outside world and finding ways of connecting to things outside of Clojure, because it's just a multiplying factor, right? We're a small community, and we thrive on the fact that we're a hosted language that can, live in the JVM or in JavaScript or interop with Python or the BLAST libraries or in this case with Mathematica and Wolfram Language. Yeah, I think it's a really cool point to just kind of stop and reflect on everything we've accomplished as a community, and nascent though it may be, that we're able to kind of punch above our weight, I think, with this kind of synergy, I guess, between all of these different pieces that we've been able to stitch together. So great to be a part of.
Cool, thank you, Christopher. Łukasz, I think Łukasz wanted to say something. Yeah, go on.
Yeah, thanks. Yeah, I just wanted to agree with Christopher that it's really nice to see how pragmatic the Clojure community is in that sense. Yesterday, when I was hearing the talk by Gerald Sussman, it was interesting to hear that it's like, okay, we don't ever want to interop with C and like, let's stay in our garden. We don't want anything from the outside or it's going to destroy our language. And from the Clojure community, it's like the other way around. Like, let all the others do the ugly work on the downstream, and we can just borrow and steal and plunder from their side and just pull it in. If it works, great. If it doesn't, well, we leave it alone for 10 years and then see if we can just rewrite the library kind of. And the same thing goes for like you said, the 10 years ago, the code was written like in a way that it would have been written in Lisp.
Common Lisp, yeah.
And these days you'll see, okay, we are doing it way more pragmatically. We are not building towers of macros, but we're trying to do something that can interop with other stuff. So like we have the Lisp curse as well, but it's not as bad since it's not all built on macros and macros and macros, but on functions on functions on functions. It's at least a little bit easier to work with other people.
Indeed, yes. So. Thank you. I would really appreciate, like I said, contributions to code. But going back to what Blaine said, like if people are working in specific areas of science, like just even posting what kind of stuff you'd be interested in, and then maybe, we could get better examples of like how, what should be our relationship with that platform, like what kind of stuff, what's the biggest point of leverage, like what we can get this because this is very unique to them, or maybe this is faster, or we could kind of, this is another lever of, this is the kind of art of using this library. Then it's like, what is the actual things that give us the biggest benefit? And we have access, and we want to make that access really good and easy to, for everyone to use. But then the next question is like, how to use it, like what's the biggest benefit that we can gain? And I would be super interested to compile like a separate repo, or maybe inside of this library, with examples of like, this is really, this is really important, this is gold, maybe in specific, maybe split into specific areas of science, or maybe in different aspects of computing. Like this is really succinct way of doing it in Wolfram language, or maybe it's very performant, those kinds of things.
Yeah. What I suggest is that maybe we will try to think about kind of hopefully concluding this and thinking if anybody wishes to kind of say concluding words. And then maybe after stopping the recording, we will just think together for a short while about other stuff.
I just want to say thank you.
Yeah, likewise. I think I said everything I wanted to say just a few moments ago, but yeah, I'll echo that. Thanks everyone for being here and being part of this. And again, it's exciting moment.